Okay, some questions to help us interpret antiderivatives. So f is given, and I want to know if its antiderivative is a, b, or c. So in other words, is it going to be a prime is equal to f? Is it going to be b prime is equal to f? Or is it going to be c prime is equal to f? So I'll use a process of deduction and see what I can see. Let's start at the bottom. Is c prime equal to f? Well, presumably you're meant to understand that c continues down forever. So this slope is getting very large, right? In fact, you could, at least to help you think, you could say, well, c prime at 0 is going to be, infinity. I wouldn't write that down. We don't like to write equations that involve infinities, but just to help us think. So c prime at 0 would be infinity. So can this be true? Well, no, because f of 0 is certainly not equal to infinity. It's not even that big. Okay, so that can't be true. How about b prime? Could b prime equal f? Well, again, I'm going to look at how b starts out. Okay, initially, right here, if I zoom in, that slope there is negative. So I could write something like b prime of 0 is less than 0. So could b prime equal f? Well, no, because f of 0 is positive, see? So it can't be that one. So it's got to be a prime is equal to f. And let's see why the rest of it makes sense. Okay, so a prime, the function a, starts out with a positive slope. And as I move left to right, the slope gets smaller along here. Okay, and you can see that f is getting smaller. And a reaches its max right here. Okay, so a prime right here would be 0, and f is also 0 there. And then this over here, the slope of f is negative, and we see that f... Sorry, let me start over. Over here, the slope of a is negative, and here we see that the function f is negative as well. Okay, so that one makes sense, and the other two do not. Okay, how about a word problem? So pause and copy this. We'll give it a try. Okay, so we have acceleration to begin with. Well, we're given deceleration, but we'll just call that a negative acceleration. So we'll call this acceleration at time t. So my acceleration function. And then we'll have velocity. Velocity will be v of t. And it's fairly standard to have s of t as your displacement. Okay, let's say, to make things a bit easier, at time 0, the brakes are applied. Oh boy. So brakes are applied at time 0. Let's make a note of that. Okay, you don't have to set it up this way, but I think this works out okay. Are applied. Applied. Are first applied. So what does that tell me? Well, it means that displacement initially Well, again, we can make a choice here. We'll say that's our starting point. So S of 0 is 0. The velocity at 0, this is what we want. This is the thing that we're looking for. So I'm going to give that a name. I'm going to call that capital V. So capital V. The acceleration is constant. Okay, the acceleration is minus 16. Okay, it's deceleration of 16 feet per second squared. Okay, so what other information do we have to use here? Well, this 200, what is this 200 here? Well, that would be where I stop, right? So let's say t is equal to, we'll call it capital T. We'll see that when t is equal to capital T, the car stops, or finally comes to a stop. So the velocity at time capital T is 0. The displacement at time capital T is, that's my 200. Okay, I'm skidding for 200 feet. Okay, so I got a whole bunch of information here. I think I want to just start doing antiderivatives and try to see how all this information comes together. All right, so I'll start with my, I guess you could think of this as my second derivative of displacement. I'll start doing my antiderivatives. So antiderivative of acceleration is going to be my velocity plus a constant here. Now I should plug in two pieces of information, this one and this one. So initially, when I plug in t equals 0, I get capital V for velocity. So that's something. V is equal to c. Then we also have this guy up here. At time t, time capital T, my velocity is 0. So 0 is equal to minus 16 capital T plus constant. So I can rearrange this, solve for c, why not? C is equal to 16 capital T. Okay, I'm just gathering some information. So I'm hoping to end up somewhere where I can solve for V. Capital V is what I want. That's my goal here. So it's a good idea to halfway through your problem just remember what you're trying to do. I'm trying to find capital V. Okay, returning to my velocity, I'll do another antiderivative to get the displacement function. So that'll give me minus 8t squared plus ct plus a constant. Now I have two pieces of information about displacement. Initially it's 0, and at time capital T it's 200. So when small t is 0, my displacement is 0. 0 plus k. So thankfully, k is 0. That's good because I don't want more variables. And now, when time is equal to capital T, I get 200. So I'll write that down. 200 equals minus 8 capital T squared plus c capital T, and we already decided that k is 0. Now what can I do? I have one equation, two variables, but look at here. My c can be replaced with, this c right here can be replaced with 16t. So it looks like I can solve for capital T. Okay, so again, this C right here is replaced with 16t. And I have one equation, one variable I can solve. Looks like t is equal to 5. Well, it'll be plus or minus 5, but we throw away the negative since we're doing physics here. Now, t equals 5. That's not the answer. That's not the question I'm trying to answer here. I'm trying to find the velocity, capital V. So I take this, t is 5, plug it back into my rectangle here. No, not that one. I'm going to need both these rectangles, aren't I? Okay, V is equal to C. That's what I found up here. And C is equal to 16t, which is 80 feet per second. So I was going 80 feet per second when I slammed on the brakes.